Hello folks, fellow YouTubers and friends. Welcome again to Boomtown Laboratories. We're the magnets that we ordered in our last video. I showed you I was cutting this piece of 6-inch ID Schedule 40 pipe for the outer covering. The outer casings of the ceiling fan, the outside of diameter fits inside this pipe absolutely perfectly. I mean, it's amazing. But anyway, thinking that the thickness of the casing would, and this being on the outside of the casing, would give me a little extra density. I mean, not density, but distance. And I went ahead and ordered, like a dummy, I ordered the 1 inch by half inch by half inch neodymium magnets and put them in here. But anyway, here they are. Okay, they pull 35.5 pounds a piece. They're roughly $3 a piece. I put 5 in here and put the stator in to see if I was going to have any clearance. Well, 4 of them are actually touching, and the 5th one that is not touching, it is so close you can't even get a sheet of paper between it. So to put all 14 magnets in here, I'm afraid it's going to be way too damn close. I mean, we're talking like 2/1000ths or maybe 3/1000ths of an inch clearance. That's just too much for me for the equipment I've got. So now there's 3 ways to remedy this situation. Some people would call it a problem. I don't. I never have a problem. I have situations that have to be taken care of. A problem is a situation you don't take care of. Okay, we said that in another video. Anyway, the 3 solutions. One is to take this into a machine shop and have them cover a groove inside that the magnet can set in and actually pull the magnets away from the stator. That would be expensive. Secondly, would be to take the stator, and because it's got bearings on it, okay, you could hold the bearings on both sides and take a belt sander, turn it upside down, or well, I've got a bench belt sander, and you could hold it on a little bit of an angle and let it spin and actually turn the stator down. Okay. Third option would be buy magnets that'll fit. Okay, that's more money, but one time. Okay, and my whole idea here is not just to do a ceiling fan conversion to a PMA, but to do a what I call DIY P&P, and that is do it yourself, plug and play. Now, what I'm trying to do is do it in such a manner that anybody in their garage with just a handful of tools can take a ceiling fan and convert it into a permanent magnet alternator very simply and very minimal time. Now, turning down the casing inside, that requires highly specialized tooling and a little bit of education on how to use tools. That question is out. Turning this down would be a plus in the fact that you'd be able to get bigger magnets in here, but at the same time it takes a lot of time and belt sanders or whatever. Simplest scenario is to buy smaller magnets but with close to the same amount of power. Now in this one, the very first one we did, we put the 1 7/8 inch long, 7/8 of an inch wide, 3/8 inch thick magnets, ceramic magnets from Home Depot, and this one worked fine. Spacing was great. 2 business cards fit in just perfectly between the stator and the magnets, which gave me a beautiful spacing. At that, they pull 4.7 pounds a piece. These pull 35.5. So your difference is 3.75 times more power, but these are not going to work unless we do the other 2 options I said. Now, what I've done is I went ahead and spent the money and ordered newer magnets, and these will be 3/4 inch by 3/4 inch by 3/8 inch, and since these were 7/8 of an inch wide and not 3/4, 3/8 of an inch thick, they fit in just perfect. So 3/4 by 3/4 should fit in and give me a little bit more gap, probably about 2.5 business cards thickness between the stator and the magnets, which is going to be really nice, really nice. Now don't ask me why this that I'm getting ready to explain, because I have no idea. A 3/4 inch by 3/4 inch magnet, it's a little bit smaller length but much wider width than a 1/2 inch by 1 inch magnet, but it's a 3/8 of an inch thick, where a 1/8 inch, the 1 by half by halves are a 1/2 inch thick. All right, here's the deal. The 3/4 by 3/4 by 3/8 inch magnets only pull 33 pounds each, which gives us exactly 7 times the power of this machine. Okay, so it'll be 7 times more power per magnet. You're putting in 14 magnets, so you're talking somewhere close to 480, 490 pounds of pull, 475 maybe. I haven't done the math on that. I do know these will be 490, and it's pulling 2.5 pounds per magnet, less of 28. Okay, about 460 pounds of pull with the new magnets. They should be here. I ordered them last night. They should be here about Tuesday or Wednesday of next week. We're going to put them in. In the meantime, you can see the markings. We have where they go. We're going to drill our holes and countersink them like we said earlier in the other video, more or less to form a rivet head of epoxy to help hold them in place. I don't foresee any problems with that. I'm getting a little anxious in finishing this project, and again, like I said, I'm not doing this to make a PMA to do anything other than make it as simple as possible. I mean, schedule 6-inch ID, schedule 40 pipe you can find in almost any scrap yard. Scrap yards normally, they buy steel for anywhere from 2 to 8 cents a pound. If of course you buy it from them, it's 60 to 70 cents a pound. Schedule 40 pipe, 6-inch diameter, 3 times 6 is 18. So 12 would be 1.5 square feet at roughly 10 pounds to the square foot. So you're talking 15 pounds a linear foot. You're using 2 inches of it. 2 goes into 15. Oh, wait a minute. 2 would be 6, goes into 15. Oh, roughly 2.5 times. So you're talking 2.5 pounds of steel here. Okay, that's just some figures off the top of my head. Anyway, like I was saying, I'm getting anxious to get this project finished so that I can move on to a project, pet project of mine that I've had in my head now for about the past 4 or 5 years. And that is a cold steam turbine. I've come up with an idea of how to produce steam at somewhere between 100 and 140 degrees. However, the steam has no pressure, so we're going to use the steam as a secondary force and to drive another force to actually turn the turbine. Now, a problem we've got with this using a ceiling fan is the wires are so small that if you put too strong of magnets in there and put too large of a load on it, it's going to heat up and burn the wires. I mean, this is a high possibility, high risk that you have if your ceiling fan turns up too fast in too hard of a wind, and you don't have some way to turn it off and let it freewheel. Like, for example, a lot of people put them in a dump load, and they dump the load into a heater to heat water. Well, you're still producing electricity, and as you produce electricity, the more actual current, not electric current, you make, the more heat you build up. Okay, so you can build a heat to the point that you actually burn your coils out. In the cold steam turbine, you're using the heat from the coils to heat the water to turn it into steam. at 100 to 140 degrees. Now, these wires will not burn out at 140 degrees. And the cold steam turbine I'm talking about building will absorb that heat that fast that they will never get over 120 to 140 degrees. Therefore, they'll never burn out. You can put magnets on these things that'll pull the world apart, and get Atlas to turn it for you, and you're still not going to burn your wires out. The wires are going to be submersed in water. The heat from the coil is going to go into the water. Now, you're probably going to have to add more heat to it, but at the same time, they're going to keep the coils cool, okay? So, like I said, I'm getting real anxious to finish this project and make sure it does work. I will not stop until it does. And again, I'm trying to make a DIY P&P. Do it yourself, plug and play, ceiling fan PMA, permanent magnet alternator. And here's another thing that I try to keep in mind when I'm doing a project is that a lot of people say there's no such thing as free energy. Yes, there is. There is no such thing as energy that is not free. And I've said this before. The energy is free. All energy is free. It is the machine, the apparatus that you need to transform one form of energy into another form of energy that you can use. The wind blows. It's energy. It's free. But you need a wind turbine to turn and move the magnets across your coils, and that costs money. The copper for the coils costs money. The magnets cost money. The housing costs money. The tower. It's all about the money per unit. Your unit of money per unit of energy that you're producing. You're not producing, you're not manufacturing, you're changing. Okay? So what I've got to do here is make sure I keep a cost in mind. What I'm saying is, if you spend $1 to build a machine that produces, $1 being 1 unit, 100 units of usable energy. Now, somebody else comes up with an idea, well, look, if you spend $2, you can make 150 units, but your cost per unit is higher. Okay? I'm not sure if everybody fully understands what I'm saying. I'm trying to get the cost per unit of output. And by unit of output, I'm not talking about over an hour's period of time. I'm talking about a month. I'm talking about for the life of the machine. This machine will not live long at all. Out in the weather, unprotected from strong winds if it's wired up wrong. Now, if it's wired up in such a manner that at a certain, output, it's going to cut off. And then it's going to freewheel. And of course, Mother Nature is going to take over and it's going to spin out of control and tear itself apart. So, there again, we're trying to do a DIY P&P. Something that anybody can build in their garage for a minimal, absolute minimal amount of money. Now, the magnets that I've ordered, that, like I said, should be in Tuesday or Wednesday of next week. They're $3.60-70 a piece. You're going to use 14 of them. However, they sell them in lots of 20. So it'd be best if you got them together, use the 14 you need, and then sell the others at a reduced price to another YouTube user that doesn't have quite the money you have, and get recoup some of your investment, but by helping someone else. Okay. All right. I'd like to say the cold steam generator or alternator or turbine has been a pet project of mine now for about 4 or 5 years, and it all stemmed from, as a child, and my father drank a lot of coffee, and he used the old style. It wasn't an electric percolator; it was the old style percolator that you put on the stove, and watching it, the top of it jiggle up and down, and that's what got me thinking. If you glued a magnet on that and put a coil around it, damn, it'd make electricity. But you got to get the water so daggone hot. Now, here's another thing that if you're going to try to watch my videos about the cold steam generator or turbine, ask somebody, what is the boiling temperature of water? 99 out of 100 people, if they know, they will tell you 212 degrees, and they will be wrong. And if you thought 212 degrees, period, end of discussion, end of answer, you were wrong. Think about that one. I mean, really, think about it. Water doesn't boil at 212 degrees. It boils at 212 degrees at sea level, which is 1,000 millibars. Water boils at 55 degrees on Mars because Mars has an atmosphere of 5 millibars. So it is possible to boil water at 100 to 140 degrees. Think about it. See you later, folks. Have fun. Have a great weekend. Oh, by the way, it's Friday, November the 1st. 2013, and it is now 2:14 p.m. Dallas, Texas time. Like I said, I like to give the date, time, and everything of each and every video I make to document exactly what's going on and when I did it. United States Patent Office accepts proof of invention by YouTube videos. So y'all, you boys that are doing things really new, need to start documenting yours with times and dates. Okay, bye-bye.